Hi everyone, a warm welcome. This is the second video of Laurent series. In this video, I am going to discuss some important problems for university examination.
Consider the question. Expand 1 by z square minus 3z plus 2 in the regions. Number 1, 1 less than mod z less than 2. Next, mod z greater than 2. Third region is 0 less than, here mod z minus 1 less than 1. Here it is mod z. So you have to express the given function in the form of an infinite series containing positive and negative powers of z. Same thing in the second region, that there also is mod z. In the third region, you can see it is mod z minus 1. So you have to express the given function in the form of an infinite series containing positive and negative powers of z minus 1. Here z minus 1 is very important. In general, suppose we wish to expand a function f is z in the region R1 less than mod z minus a less than R2. Then its Laurent series expansion is in the form of an infinite series containing positive and negative powers of z minus a. In general, we can express it as a0 plus a1 into z minus a plus a2 into z minus a the whole square plus etc. This is the infinite series containing positive powers of z minus a and b1 by z minus a plus b2 by z minus a the whole square plus etc. And it is infinite series containing negative powers of z minus a. See, in the first two questions, it is mod z. So the expansion is in the form of an infinite series containing positive and negative powers of z. See, in the last question, in the last region, it must be in the form of an infinite series containing positive and negative powers of z minus 1. See, this is the general form of the Laurent series expansion of f z in this angular region. Here, by the nature of the given function, sometimes some coefficients, that is ai or bi, may be absent. And really, this part is known as its singular part or principal part. That is the singular part. And here, this b1 has some importance. If a is a singularity of f is z, then b1 is the residue of f at a. That is not the part of our Laurent series. Say b1 has some importance, I just mentioned. Let me answer the question. First, you have to give the partial fraction. Clearly, z square minus 3z plus 2 is z minus 2 into z minus 1. And its partial fraction is, its numerator is, you put z equal to 2 here, it is 1. Its numerator is, you put z equal to 1 here, it is minus 1. See, this is its partial fraction. Next, you consider the first region. First region is 1 less than mod z less than 2. It can be written as 1 less than mod z and mod z less than 2. For our convenience, you express this inequality less than 1. For that, you take mod z to the left side. Here also you take 2 to the left side. So the given region is split into two regions, 1 by mod z less than 1 and also we have mod z by 2 less than 1. Here, z minus 2 can be expanded in this region if mod z by 2 is less than 1. That is possible by taking minus 2 outside. Then it is 1 minus z by 2. See, in the second term, you take z outside, then 1 minus 1 by z. Clearly, 1 by mod z is less than 1. So you can expand these two terms by using these results. Always keep in your mind, you can apply these two results only if mod is less than 1. That is, modulus of the second term in the denominator should be less than 1. Here mod z by 2 less than 1. Here 1 by mod z less than 1. Now it's ready for applying that result. So you apply it. You can see. See, this can be written as and then its infinite series expansion is 1 plus z by 2 plus z by 2 the whole square plus etc. minus 1 by z into 1 plus 1 by z plus 1 by z the whole square plus etc. That is minus 1 by 2 into 1 plus z by 2 plus z square by 2 square plus etc. You should be very careful while writing 2 and z minus 1 by z plus 1 by z square plus 1 by z cube plus etc. That is, see, the given function in the region 1 less than mod z by 2 can be written as two infinite series. One is positive powers of z and the second series is negative powers of z. That is the Laurent series expansion of this function in the region 1 less than mod z less than 2. Next, consider the second region. Our second region is mod z greater than 2. That is, you write inequality less than 1. That is 2 by mod z less than 1. So the given region is 2 by mod z less than 1. We have one region here. So from this region, with the help of this region, you have to express both terms in the form of an infinite series. So here, you take z outside, 1 minus 2 by z. So modulus of the second term, that is 2 by mod z, which is less than 1. So it is suitable for expansion. Next, minus 1 by z minus 1. You take z outside. 1 minus 1 by z. See here, 2 by mod z less than 1. So what about 1 by mod z? 1 by mod z is also less than 1. See, 1 by mod z less than 1. So its 2 times is also less than 1. See, the given region is 2 by mod z less than 1. That is 2 times of 1 by mod z is less than 1. So 1 by mod z is always less than 1. So you have to rewrite z minus 1 in the form z into 1 minus 1 by z. First you watch carefully and you apply these in problems. Then you can easily identify how to rewrite the denominator term. Only through practice you can easily rewrite. So practice well. See, this is 1 by z into 1 minus 2 by z raised to minus 1 minus 1 by z into 1 minus 1 by z raised to minus 1. That is 1 by z into its expansion is 1 plus 2 by z plus 2 by z square plus etc. minus 1 by z into 1 plus 1 by z plus 1 by z square plus etc. That is 1 by z plus 2 by z square plus 2 square by z cube plus etc. minus 1 by z minus of 1 by z plus 1 by z square minus 1 by plus 1 by z cube plus etc. See, this is the infinite series expansion of a given function in the region mod z greater than 2. Unfortunately, the positive powers of z is absent. Again, you can combine like terms. So this will cancel each other. You can combine. That's not necessary. mentioned, in this region you have to expand the given function in the form of an infinite series containing powers of z minus 1. The given function is one by z minus 2 minus 1 by z minus 1. And we used to express in powers of z minus 1. See the second term. See, it's in the form of a term with the z minus 1. So there is no need of rearranging or expanding this second term. So you keep it as safe. Next you expand the first term. See, the first term is 1 by z minus 2. Always you remember an expansion must be in powers of z minus 1. So for expanding in powers of z minus 1, you make a rearrangement in the denominator by keeping z minus 1. So you rewrite minus 2 as minus 1 minus 1 and you consider this as a single term. And with the help of the given region and these results, you expand this term. Then you can see it is in the form of a series containing powers of z minus 1. The given region is mod z minus 1 less than 1. So you here, you will take minus 1 outside. We can rewrite the denominator like this. Now the starting term is 1 and modulus of the second term is less than 1. Now it's suitable for applying our basic results. And its expansion is minus, see this is 1 minus z minus 1 raised to minus 1, minus 1 by z minus 1. That is minus of 1 plus z minus 1 plus z minus 1 the whole square plus etc. minus 1 by z minus 1. See, this is our given function in the third region. See, the right side is in the form of an infinite series containing powers of z minus 1. See, in the right side you can see there are infinitely many elements in the positive powers of z minus 1. But in the negative powers you can see only one term, that is 1 by z minus 1. Really b2, b3 etc. are zeros. And see, now see, all the terms are powers of z minus 1. See the 1, the first term 1, the constant 1 can be written as, there is no need of rewriting 1, but you can consider it as z minus 1 raised to 0. Now all the terms are in powers of z minus 1. So that's the required Laurent series expansion of the given function in the region 0 less than mod z minus 1 less than 1. Next question, find out Taylor series and Laurent series of f is equal to minus 2z plus 3 divided by z square minus 3z plus 2 in the regions. First one, mod z less than 1. Second region, 1 less than mod z less than 2. Really the question is, find all Taylor series and the Laurent series. See, in such regions, you can find its Laurent series. So you find its Laurent series. So before expanding, you have to give the partial fraction of the given function. So consider f is z as minus 2z plus 3 by z square minus 3z plus 2. Before starting partial fraction, you factorize the denominator completely. Now the partial fraction of this function is a divided by z minus 1 plus b by z minus 2. Numerator of z minus 1 is, you put z equal to 1 here. Then you can see minus 2 plus plus 3 by minus 1. That is 1 by minus 1. It is minus 1. For getting the numerator of z minus 2, you put z equal to 2 here. And it is minus 4 plus 3 by 1. That is minus 1 by 1. That is minus 1. Which is the partial fraction of the given function. So we have minus 2z plus 3 by z square minus 3z plus 2 is equal to minus 1 by z minus 1 minus 1 by z minus 2. Next, consider the given region, that is mod z less than 1. Next, you rearrange these two terms suitable for applying our basic results in this region. For that, here mod is less than 1. So in the denominator, you take minus 1 outside. It is 1 minus z. Now 1 by 1 minus z is ready for expansion because mod is less than 1. Next, minus 1 by, here if you take minus 2 outside, then you can see it is 1 minus z by 2. Given mod is less than 1. So, its half is also less than 1. Mod z less than 1. So, half of mod z is also less than 1. So, mod z by 2 is less than 1. So, now you can expand 1 by 1 minus 1 by z by 2 in the form of an infinite series. Now, this is equal to 1 by 1 minus z plus 1 by 2 into 1 minus z by 2 equal to, it is 1 minus z raised to minus 1 plus 1 by 2 into 1 minus z by 2 raised to minus 1. Its expansion is 1 plus z square plus etc. plus half into 1 plus z by 2 plus z square by 2 square plus etc. See, now this is in the form of an infinite series containing powers of z. Fortunately, here only positive powers of z, no negative powers of z. And this is the required Laurent series expansion of minus 2z plus 3 by z square minus 3z plus 2 in the region mod z less than 1. Here, in the expansion, only positive powers of z. There is no negative powers of z. So, we can consider this as the Taylor series expansion of the given function. Next, consider the second region, which is 1 less than mod z less than 2. In such regions, you have to split the region. That is, 1 less than mod z and mod z less than 2. And for the convenience of expanding these two terms, you write which is less than 1. So here, you have to take mod z to the left side. So the region is 1 by mod z less than 1 and mod z by 2 less than 1. Next, by looking into this region, you rearrange these two terms. So its rearrangement is minus 1 divided by, here 1 by mod z is less than 1. So you take z outside. So z into 1 minus 1 by z. That's ready for expansion. Minus 1 by, we have mod z by 2 less than 1. So you make it z by 2. For getting z by 2, you take minus 2 outside. 1 minus z by 2. Now it's ready for expansion. And this is minus 1 by z into 1 minus 1 by z raised to minus 1 plus 1 by 2 into 1 minus z by 2 raised to minus 1. It is minus 1 by z, 1 plus 1 by z plus 1 by z square plus etc. plus 1 by 2 into 1 plus z by 2 plus z square by 2 square plus etc. See, if there is z outside, you take it to the bracket. that is minus 1 by z plus 1 by z square, it's not necessary, plus half into 1 plus z by 2 plus z square by 2 square plus etc. See which is the required Laurent series expansion of the given function. Next expand z square minus 1 by z square plus 5z plus 6 in the region 2 less than mod z less than 3. So you start with partial fraction. Really, it's partial fraction which is a misleading for almost all students. So while giving partial fraction of any function, you must check whether degree of numerator is less than degree of the denominator. You can give partial fraction for any function only if the degree of the numerator is strictly less than degree of the denominator. If degree of numerator is greater or equal of the degree of the denominator, then you can't directly give its partial fraction. See, in this situation, first you have to divide for making degree of the numerator less that of degree of the denominator. So you should be very careful in such questions. Here, degree of the numerator is 2 and degree of the denominator is 2. So you can't give its partial fraction directly. So first you have to divide and then you make degree of numerator less than degree of the denominator. Then you can give the partial fraction. Let me do it. For that you first divide. So z square minus 1 divided by z square plus 5z plus 6z. 1, you multiply this one, that is z square plus 5z plus 6. Next, subtract. See, in numbers, suppose we wish to divide 26 by 8. Then, we know, here 3, then 8 into 3, it is 24. Here multiplication. Here also multiplication. 1 into z square plus 5z plus 6. Next, you subtract 24 from 26, that is 2. Then you write 26 by 8 is equal to 3 plus 2 by 8. So here you subtract z square will cancel, minus 5z, minus 1 minus 6, that is minus 7. So we can write z square minus 1 by z square plus 5z plus 6 is equal to 1 plus minus 5z minus 7 by z square plus 5z plus 6, like this. Now you look into the right side. Here you have to put the partial fraction. Here degree of numerator is 1, degree of denominator is 2. So you can directly give its partial fraction. In almost all questions, degree of numerator will be less than degree of denominator. But in few questions, degree of numerator will be greater or equal while comparing with the degree of the denominator. In such questions, you should be very careful and you divide like this and you write like this. Next, you give its partial fraction. So we can write 1 minus 5z plus 7 by z square plus 5z plus 6z. That is 1 minus of 5z plus 7 by z plus 3 into z plus 2. And its partial fraction is you put z equal to minus 3 here, then minus 15 plus 7 by minus 1. That is minus 8 by minus 1, that is 8. Next you put z equal to minus 2 here. Here you put z equal to minus 2, that is minus 10 plus 7 by 1, that is minus 3. So it is by z plus 2. Next, consider the given region. Given region is 2 less than mod z less than 3. In such regions, you have to rewrite it as, here it is 2 by mod z less than 1 and mod z by 3 less than 1. Next, you rewrite these two terms conveniently for applying these results. 1 minus 8 by mod z by 3 is less than 1. So you keep z by 3 here. For that you have to take 3 outside. For expanding this one, you have to make the first term 1 and what is the second term is 1. So for here you have to take 3 outside, 1 plus z by 3. Here modulus of z by 3, that is mod z by 3 is less than 1 plus 3 divided by, we have 2 by mod z less than 1. You have to keep 2 by mod z, for that you have to take z outside. Z into 1 plus 2 by z. Now it's ready for expansion. This is 1 minus 8 by 3 into, you take this raised to minus 1, then 1 minus z by 3 plus z square by 3 square minus etc. plus 3 by z into 1 plus 2 by z raised to minus 1. While writing 2 and z, very careful. 1 minus 2 by z plus 2 square by z square minus etc. That is, the series is 1 minus 8 by 3, 1 minus z by 3 plus z square by 3 square minus etc. plus 3 into, you keep the constants outside. You take all the z functions to the bracket. 1 is 1 by z minus 2 by z square plus 2 square by z cube minus etc. which is the required